Hello everyone, and welcome to today's video. Today we'll be going over some competition problems involving computations with fractions. This first problem is from the 2019 AMC 8, problem number 3. Which of the following is the correct order of the fractions 15 over 11, 19 over 15, and 17 over 13 from least to greatest? For those of you who'd like to solve the problem on your own, please pause the video in the next 5 seconds. Alright, I'll begin to solve the problem now. For this problem, there are two approaches I would take. One is a more traditional mathematic way that anyone would take when comparing fractions. The other is a more intuitive way, and it's a little trickier, but significantly faster and easier once you understand the concept of it. So first I'll be going over the traditional mathematical way, and then transition into going over the intuitive method. First, the traditional mathematical way of doing this is just to find the greatest common denominator so that we can better compare the fractions 15 over 11, 19 over 15, and 17 over 13. Right now, we can't compare them because we don't know what the difference between 15 elevenths is between 19 fifteenths. To do so would require essentially perfect visualization of perhaps like a pie, and that's not something we can readily do in our minds. So we want to change all of these fractions to be out of the same number of parts, meaning they have the same denominator. For example, if I wanted to compare something like 3/4 versus 5/7, it would be kind of confusing, right? Sevenths and fourths are different, so I don't know if 3/4 is greater than 5/7 or the other way around. However, if we change these to have the same denominator, which would be the greatest common denominator between 4 and 7 is 4 times 7 is 28. So it ends up being 21 over 28 versus 20 over 28. Now, since they have the same denominator, we can easily tell that 3/4 was greater than 5/7. That's what we want to do for this original problem. And to do so, we can look at 11, 13, and 15. Unfortunately, they don't share any common factors. So your greatest common denominator will be 11 times 13 times 15. That's a huge number, and it ends up being 2145. So the reason you wouldn't want to do this in this traditional method during a competition-style math problem is because competition-style math problems are for competitions. Competitions have specific time limits, and you want to be able to solve each problem as fast as possible. So when you're changing all of these fractions into their respective fractions with this denominator, I would have to multiply 15 by 13 and 15, 19 by 11 and 13, and 17 by 11 and 15. That's so much multiplication, and that's really big numbers. You don't want to be doing this and wasting time when you could be doing another problem and moving on. So in the end, you would have to multiply these out and then compare them to see which has bigger numbers. But there is an easier way, and the intuitive way of doing this is to sort of recognize something. This method won't necessarily work for every single problem, but it works because of one specific reason. Each of these fractions, their numerator is greater than their denominator by 4. And what that means is that we can kind of separate them into something that we can understand better. For example, 19 over 15 is 1 and 4/15. 17 over 13 is 1 and 4/13, and 15 over 11 is 1 and 4/11. So each of these fractions have 1s, so we can ignore those. Now all we're doing is comparing these fractions, 4/11, 4/13, and 4/15. How do we do that? Well, we just think about something. Fractions are essentially parts of a whole. And a fraction with a denominator of 11 is saying that there are 11 parts to make a whole. So a fraction with a denominator with 13 would be that there are 13 parts to make a whole. And if these wholes are the same, for example, these wholes are the same, like think about it as a pie, these slices on the 11 pie would be bigger than the slices on a 13 pie. Because you want to add up to the same thing, but this one has more parts. So since each of these is 4 of the same part, except they have different slices, different sized slices, we know that 4/15 has to be the smallest one, followed by 4/13, followed by 4/11. So by intuitively breaking it down and recognizing that each of these is 4 of their respective denominator more than 1, we can easily just look at it and realize, oh, it's just 4 of each thing, but each of these things or these slices are different sizes. And so your answer ends up being this, E. Alright, I will be moving on to the next problem. Oh, excuse me. This problem was taken from the 2018 AMC 8 number 10. The harmonic mean of a set of non-zero numbers is the reciprocal of the average of the reciprocals of the numbers. What is the harmonic mean of 1, 2, and 4? For those of you who would like to go over the problem by themselves, please pause the video in the next 5 seconds. Alright, I'll start going over the problem now. Phew. This problem is kind of a mouthful and it seems really intimidating. But if we divide it into parts, we can make the problem a lot easier. So what do we want to do first? This problem wants to find the reciprocal of the average of the reciprocals of these numbers. Well, first, let's do everything backwards. We want to find the reciprocals of the numbers first. That's our first step. And then our second step is to find the average. Then our third step would be to find the reciprocal of that average. For competition problems that are very complicated like this one, you want to add out and map out your steps so that you have a plan and you know where you are. Because it's easy to get confused. Wow, there's 3 reciprocals in this question. What am I going to do? Which reciprocal am I at again? If you have a plan, you won't have to ask questions like that and you will be able to quickly solve the problem. And it saves more time than you'd think. Alright, so we just have to start with step 1, find the reciprocals of numbers. For those of you who don't know, a reciprocal is essentially the opposite of that fraction. For example, let's take 3/7. I would flip this over and to find the reciprocal, which is 7/3. So the reciprocal is essentially saying flip the fraction over, switch the numerator and the denominator. So something like 3/8 would become 8/3, or 2/3 would become 3/2. The only time something like this might be confusing is you can find the reciprocals of things that aren't fractions. Like, for example, the number 9. I can find the reciprocal of this because 9 is essentially 9/1 as a fraction. 9 divided by 1, so it's actually still 9. But if I find the reciprocal of 9/1, it becomes 1/9. So you can find the reciprocal of anything, and what's interesting about reciprocals is if you multiply the two of them together, they always multiply to 1. For example, 3/7 multiplied by 7/3, the 3 and the 3 cancel out, and the 7 and the 7 cancel out, so you're left with 1. The same thing with 9 times 1/9. The 9 and the 9 cancel out, and you end up with 1. So that's essentially what reciprocals are. I'll erase that really quickly. Now, let's find the reciprocals of the 3 numbers given, 1, 2, and 4. So 1, the reciprocal is 1. Why is that? 1 is 1/1, and the reciprocal of that is 1/1. So 1 is that number that if you take the reciprocal of it, it's exactly the same number. So that's the first reciprocal. 2. 2 is the same thing as 2 over 1, and if we take the reciprocal, it's 1/2. 4. 4 is the same as 4 over 1, and the reciprocal is 1/4. Alright, that's step 1 finished. We have our reciprocals. Cool. Let's check that off. Step 2, we need to find an average of those numbers. For those of you who don't know, an average is kind of just saying, if we add all of these numbers up and divide them by the number of numbers there are, what number is it? Like, kind of the middle number out of all of the sets, if we add them up and just look at them. So, how you find the average is quite simple actually. You add up all the numbers, in this case 1 plus 1/2 plus 1/4, and you divide by the number of numbers that you added up. In this case we added up 3 numbers. So that's essentially it. That is the equation for the average right now. And we just have to solve. So 1 plus 1/2 plus 1/4 is the same thing as 1 plus 3/4 over 3. And it's the same thing as 4 over 4 plus 3/4 over 3, which is equal to 7/4 over 3. Now, 7/4 over 3 is the same thing as 7/4 divided by 3. And for those of you who didn't know, division by fractions is the same thing as multiplying and finding the reciprocal of the second number. There comes reciprocals again. So 7/4 divided by 3 is the same thing as 7/4 multiplied by 1/3. And so your answer is 7/12. That is your average of those numbers. So that's step 2 done. Let us write down that step 2 was equal to 7/12 and erase this to make some more space. Finally, we just need to find the reciprocal of the average. That's step 3. And we know how to do this already. And it's rather simple. So we have the 7/12. What do? We just flip it over. 12 over 7. Alright? That's step 3. Hey look, we finished the problem. So having these steps just makes it really easy to move from step to step, see where you're messing up, or if you look back on it, it's easier to check your work because you can say, okay, I did this part right. Did I do this right? Okay, what about the next step? And then you can do that over and over to check your work. So in this problem, your answer ends up being 12 over 7 is the harmonic mean of 1, 2, and 4. Thank you guys so much for watching this video on computing with fractions. See you guys next time.